If a massive solar storm that could wipe out power grids across the U.S. and other parts of the world was headed towards Earth, could there be a way to stop it? That's a question a group of scientists are trying to figure out. They recently proposed creating a satellite constellation called a StormWall to help shield the Earth from the impact of a potential solar storm. The model would essentially serve as an airbag in space to work as a barrier. NASA defines a solar storm as a broad term for sudden intense explosions of energy, magnetic fields, and charged particles from the sun. One of the storms the scientists modeled their concept on was the May 2024 solar storm Gannon. According to Minnesota Public Radio News, it cost U.S. farmers around $1 billion in damages, or roughly $17,000 per farm, as a result of the storm across the Dakotas and Minnesota. Brian Walsh is one of the co-designers of the StormWall. He's also an associate professor of engineering at Boston University. First of all, thank you so much for being here. Can you explain why this is something we need?
Absolutely. Well, there's a couple pieces that link to this. And the first one is why an average person might care about space in their day-to-day life. And in 2026, it turns out almost every person relies on space or space assets just about every day. And we can look at some examples of this. Basically, every financial transaction right now relies on timestamps from satellites. Much of our agriculture at this point relies on GPS positional sensing for managing and maneuvering tractors. Some of our shipping at this point, and defense is also a major piece of this. And so these are all the reasons we would care about it. And the next piece is the space weather element and why our space environment is vulnerable. And space weather in many ways is a silent killer. When weather happens on Earth, we can feel wind, we can see a tree get knocked over in a storm, but in space, we have these major space weather storms, and we don't necessarily see them with our eyes. There are things like a satellite can get knocked out, or currents can be driven into our power grid and cause damage that we don't necessarily see, but they're just as painful and just as damaging. And when we map these harms to financial costs, people estimate the 100-year type storm for space weather, the damage would be somewhere between $2 and $4 trillion. And so this is really significant. We look at a 100-year type storm on terrestrial weather and types of storms that come up, or Hurricane Katrina. The damage from that was about 10 times less. It was about $100 billion. And so these things are important and things we need to think about as a civilization.
We talked a little bit about how it would work. If you could expand on that for us. And then also, how would the StormWall be deployed? Who would pay for it? And would it stay in space indefinitely?
Yeah, absolutely. There's always challenges with types of solutions that require rapid response. And fortunately, this is not exactly one of those types of solutions. We could launch a group of satellites into space, and they could just be there ready. We wouldn't have to press a button to launch or to fuel up a rocket to launch immediately when we think there's an explosion on the sun. We could launch our constellation into space. It could be there waiting for us. And when we think there's a large explosion on the sun, we see a large flash and it's streaming towards space to energize our space environment and hammer us with space weather, we can start releasing the gas from these satellites that will then protect us in space.
Why now? Why is this so important to talk about now?
Well, it's always been a challenge for humans. We've just never had a solution before now. And historically, we've spent years and years. Mark Twain has this line, people are always talking about the weather, but nobody's doing anything about it. And for many years, that's the space weather world. We've been trying to build better models, longer range prediction, more accurate, but we never had a way of stopping it. And this is the first step to do that.
Brian Walsh, thank you.